Welcome to Homework Lib.
We have a dot plot here representing a sampling distribution. So the general shape here is approximately normal. That does not surprise me at all because of the central limit theorem. As sample size increases, the statistic becomes more and more normally distributed if we're looking at sample proportion or mean. So we have this approximately normal distribution representing samples of size 500. Each dot represents one such sample. So each dot in this curve is the sample proportion that was found for a particular sample. So one sample. And its sample proportion. So the height of any particular value tells you how many samples had that sample proportion. Part B. If we took samples of size 1000 instead, what would happen? So the standard error is given, actually I'll start with the binomial, because initially you have a binomial. N is 500 or 1000, so we'll start with 500, and probability P is the population proportion, also the probability each member of a sample meets the criteria. The standard deviation of the binomial is root NP 1 minus P. If we're looking at the standard deviation of P hat instead of the binomial variable x, you just divide by n. So this is the standard deviation for the number in the sample that meet the criteria. To get the standard deviation of the proportion, I divide it by n, and this is also called the standard error. It is the standard deviation of the sampling distribution. So this is the formula for the standard error. Notice n is in the denominator here. So if n increases, the standard error gets smaller. So B is the answer. C. We take a sample of size 500, and we get P hat, the sample proportion, is 0.37. Is that likely? So if we look at where that is on our curve, it's way out here. 0.37 is very extreme. There are 4 samples that had something higher than that. So this is very unlikely. It's possible, but not very likely. We'll go with option C. We wouldn't be utterly shocked to see it, but it would be quite a surprise. Now, part D, what if we found P equal to 0.3? Comparatively, this is in the kind of bulk of the data set. This is likely. We wouldn't be surprised at all. This is very expected to occur.